go through this. This is section, actually it's now 1.6. It used to be section 3.7. They just shifted in the book. It's still something that we need to cover. We talk about quadratic inequalities. We talk about polynomial inequalities. We'll do those today. And then the rational inequalities will hit tomorrow. So I did not want to put this on the test with all the other information, even though it has traditionally been in chapter 3. So we're just going to cover this kind of as a mini unit, mini lesson. All right, quadratic inequalities. Okay, without graphing. Okay, so graphing, if you have a good idea of the picture of the inequality or of the quadratic, it'll give you a good idea what the inequality answer should be. But I'm going to show you what's called a sign chart to solve this. We want to know where this equation is greater than 0. So if you plug in a number, will you get back a positive answer? Will you get back a negative answer? Well, we want to know where it's greater than 0. What aids us is where it equals 0. So that's essentially what we want to do, is figure out where it equals 0. And we do that just as you would an equation that equals 0. And for a quadratic, we're going to factor it. And that's going to factor into x plus 5 times x minus 2. And so let's just figure out where it equals 0. Well, that's going to be where x equals negative 5. Just set both of those equal to 0. And x equals positive 2. Well, if that's where it equals 0, it has to be either negative or positive to the left of negative 5, in between negative 5 and 2, and to the right of 2. These are the only spaces it can equal 0. These are kind of your breakpoints. So that's why I got this graph down here. So negative 5 is one breakpoint, 2 is the other. And in between and to the left and right, it has to be either greater than 0 or less than 0. Well, we're going to do this little test point method. And we're going to pick a point from each of these regions. Okay, we got 3 regions here. Okay, there's your first region. Here's your second region. And then here's your third region. And we're going to pick a test point and see whether that point comes back negative or positive, because all the points then would be the same. We'll leave that. All right, it doesn't matter what your test point is. So for this one here, I'm going to use x equals negative 7. Here, I always try to use 0 if it's available. And then I'm just going to make this one x equals 5. You can plug it into the original function, but what is a lot of times a little bit easier is if we plug it into the factored form. So that factors into x plus 5 times x minus 2. And really all I'm concerned about whether it's positive or negative in the end. So if I plug in negative 7 plus 5 is a negative number. Negative 7 minus 2 is a negative number. And a negative times a negative is going to give me a positive. So that basically means that everything in this area will come back positive. I don't need to check every number. I just need to check one of them, because we got our breakpoints where it does equal 0, and then everything else will have to be positive or negative. It cannot flip from positive to negative anywhere there, or else it'd have to cross the 0 or the axis again. All right, I got 0. Again, I'm going to use x plus 5 times x minus 2. 0 plus 5 is a positive because it's 5, and 0 minus 2 is a negative. Whoops, and it's negative 2. Well, positive times a negative is going to be negative. So that means everything in this range will be negative. Now I'm going to use 5. I'm going to plug it into x plus 5. I'm going to plug it into x minus 2. Well, 5 plus 5 is a positive number. 5 minus 2 is a positive number. Gives me a positive value. We'll go back to your original inequality. They want to know, when's it going to be greater than 0? Okay, well, it's going to be greater than 0 wherever the end result is positive. So it's going to be here, and it's going to be here. So we're just going to put our answer. It's going to be wherever x exists from negative infinity all the way to negative 5. union from 2 to infinity. So those are all the x values when I plug into the original will give me a number greater than 0. So this is like we call a sign chart or a sign diagram to indicate it. So we just pick a test point, see whether we get a positive or negative back. And we got to figure out where it hits 0 first. All right, second one here. I want to figure out what x squared is less than or equal to 2x plus 2. Well, this isn't going to be easy unless you set it equal to 0. And so we're going to take x squared minus 2x minus 2, and we want to know where that's less than or equal to 0. Well, we want to factor it. Well, unfortunately, this does not factor. We still need to know where it hits 0. And to figure out where it hits 0, we got to solve where this equation where it equals 0. Well, if it doesn't factor, got to use quadratic root formula. X equals the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. All right, well, a is 1, b is negative 2, c is negative 2. The opposite of negative 2 would be 2, plus or minus negative 2 squared minus 4 times 1 times negative 2 over 2 times 1, which is just 2. All right, simplify this. 2 plus or minus. All right, negative 2 squared is 4. Negative times a negative is a positive. So we get 4 plus 8, which is 12, divided by the 2. All right, square root of 12 reduces to 2 square root of 3. And then when we're done, 2 divides into both of those. We get 1 plus or minus square root of 3. All right, so those are your zeros. 1 plus square root of 3, 1 minus square root of 3. Well, we're used to having whole numbers or fractions. Those are still equal to 0. They're real numbers. We got to account for them. So if I go to my calculator and I say 1 plus square root of 3, I get 2.7. So 2.7 is right about there. That is 1 plus square root of 3. And then the other one is 1 minus square root of 3. And I get negative 0.73. So it's going to be 1 minus square root of 3. All right, I'm going to pick a test point. I got 3 areas I need to worry about. So I got this area here, all the way up to that 1 minus square root of 3. I got the area in between I need to worry about. And I got the area to the right I need to worry about. And I need to pick one test point in each of those 3 areas. I'm going to use negative 3. I'm going to use 0. And I'm going to use 5. Those are going to be my test points. Okay. Now, in the last one, I plugged it into the factored form. This one did not factor. So I'm going to need to plug it into x squared minus 2x minus 2 and see whether it's going to give me a number less than 0 or a number bigger than 0. And so negative 3 squared minus 2 times negative 3 minus 2. What is that? 9 plus 6 minus 2. So I get 13. So I get a positive number. So everything will be positive all the way to that 0. Okay? Don't stop at the checkpoint. Go all the way to the 0, which is right there. All right, when I plug in 0, you get 0 squared minus 2 times 0 minus 2. You're left with negative 2. So we get a negative there. And when I plug in 5, 5 squared minus 2 times 5 minus 2, I get 13. And so all of those values are positive. All right, well, the final answer, or the answer to the question, it wants to know one will be less than or equal to 0 after you move everything over. It's going to be equivalent to what we got there. Well, where's it going to be negative at? It's going to be negative in between the two zeros. So my solution will be x exists in the interval from 1 minus square root of 3 to 1 plus square root of 3. Okay, so all those values will solve that inequality. So if it factors, I would just plug it in and worry about what the sign of the final answer is. If it doesn't factor, you got to substitute it in, see what you come up with. All right, third one here. Again, set it equal to 0. Or you get 0 over here, so it's going to be x squared plus 4x, add 6, plus 6 is less than or equal to 0. All right, we got another case here. This does not factor. This does not factor, so I use quadratic formula. A is 1, B is 4, C is 6. All right, so the opposite of 4 is negative 4, plus or minus 4 squared minus 4 times A, which is 1, times 6, over 2 times 1, which is 2. Well, I get negative 4 plus or minus square root. All right, that's going to be 16 minus 24, which is negative 8, over 2. That's negative 4. All right, square root of 8 is 2 square root of 2 when you're done. The negative will give me an I over 2, and then when I am done, I get negative 2 plus or minus I square root of 2. Well, I really didn't need to keep going if you recognize something here. We got complex answers for our zeros. That means they don't exist on the real number system. That means it doesn't hit the x-axis. Well, if that's the case, then it has to be one of two things. If it can't hit the x-axis, it needs to be above it or below it. Well, go to what we know for x squared plus 4x plus 6. It is a parabola that opens up. So since it does not hit the x-axis, it must be shifted above the x-axis. Well, the question asks, for what numbers can I plug in? Will it be less than or equal to 0? Well, if that's the case, then it will never be less than 0 because it never goes below the x-axis. So in this case here, we get no solution because it's never going to go below the x-axis. Right, that leads to what's called the one-sign theorem. Okay, if a polynomial equation has no real solution, okay, that means you have complex numbers, then the polynomial is either always positive, which means it's in this case, since we're talking about quadratics, a parabola that opens up, or it's always negative, which means you have a parabola opening down. Okay, but it's a one-sign theorem. They're always positive, okay, or always negative for that case. And that's when you have complex answers. All right, now that's mainly for quadratics on those first few. Okay, we have other situations here where we have higher degrees than 2. All right, now this one here, this one's already, the hard work's already been done for you. Already been done for you. Don't multiply it back together. We want to know where it's going to equal 0. As long as this is a 0 on the right side, all I got to do is set each of these equal to 0. and solve for the 0. And so I got x minus 2 equals 0, which means x equals 2. I got x minus 8 equals 0, which means x equals 8. So those are kind of my breakpoints. That's where it equals 0 at negative 3, at 2, and at 8. So in between here, it either has to be greater than 0 or less than 0. And I'm going to test it using a sign chart. So I need a number to the left of that 0, a number in between those two zeros, a number in between 2 and 8, and then a number here. Those are my test points. So I'm going to use negative 6. Hold on here. Let me use black. X equals negative 6. I always try to use 0 when I can. I'm going to use 5, and I'm going to use 10. Okay, take your original, x plus 3, since it's in factored form, x minus 2, x minus 8, and I'm going to plug in negative 6. Negative 6 plus 3 is a negative. Negative 6 minus 2 is a negative. And negative 6 minus 8 is a negative. If you multiply 3 negatives together, your final result will be negative. So every number in here, as long as I've done this right, will give me a negative answer. All right, I'm going to use 0. All right, 0 into x plus 3 is a positive. 0 into x minus 2 is a negative, and 0 into x minus 8 is a negative. All that being said, it ends up being a positive. A positive times a negative is a positive. Pick 5. 5 plus 3 is 8, which is positive. 5 minus 2 is 3, which is positive, and 5 minus 8 is a negative. Well, two positives and a negative will multiply together to give a negative. Oh, let me go back here. I got all positives here, and then I got all negatives here, and now pick 10, and 10 plus 3 is 13, which is positive. 10 minus 2 is 8, which is positive, and then 10 minus 8 is 2, which is positive. 3 positives are still positive. Okay, well, I want to know where it's greater than or equal to 0. Greater than or equal to 0 is where you get positives back. It's going to be in these two sections here. So my answer is going to be where x exists. Don't forget to go from your breakpoint. And since it's equal to 0, I include the point. Negative 3 to 2, union, positive 8 to infinity. Okay, any number in those two intervals will give me an answer greater than 0, a positive answer. All right, one thing you got to watch, and so far to this point, it's always alternated negative, positive, negative, positive. That does happen quite often, but it does not happen every time. Do not automatically assume like, oh, first one's negative, I'm just going to go positive, negative, positive. Okay, that's not the case every time. Okay, often, but not every. All right, let's take a look at one more of higher degree. X cubed is less than 9x. Okay, first thing you want to do is we want to subtract 9x. You want to avoid dividing by x at all costs. That will give you the wrong answer. Basically, it eliminates one of your zeros. And then you will be doing the problem not realizing that there's another 0. What you want to do is when you have that x in both terms is you want to factor it out, because that'll give me x squared minus 9 is less than 0 times x. Well, x squared minus 9 factors again. into negative 9, or excuse me, negative 3 and positive 3. We want to know where it's going to equal 0. Well, here we got 3 cases. When x equals 0, if I solve that one, when I get x equals 3, and then I get negative 3. So at negative 3, at 3, or excuse me, at 0, and at 3. Okay, so everything here. And then in between negative 3 and 0, between 0 and 3, and 3 to the right, 3 to infinity. I need to check a number from each one of those and then test it and see what we get. So I'm going to use negative 6. That is my test point. I'm going to use negative 1. All right, I said I always like to use 0, but I can't if it is one of my zeros. So use 1, and then I'm going to use 6. And I'm just going to check to see whether I get a positive or negative. And I'm plugging it into the x. Actually, right. Let's see what happens here. This is what I'm plugging it into. Okay, and take your test point. Negative 6 goes in for x, which is negative. Negative 6 minus 3 is a negative 9, which is negative, and negative 6 plus 3 is another negative. 3 negatives multiply together and stay negative. So every number in here give me a negative number. All right, negative 1 in for x will give me negative. Negative 1 minus 3 is negative 4, and negative 1 plus 3 is a positive. That gives me a positive. So everything in here is positive. Plug in 1. 1 minus 3 is negative. 1 plus 3 is positive. 2 positives and a negative will give me a negative. And then plug in 6. I get a positive. 6 minus 3 is a positive, and 6 plus 3 is a positive. 3 positives will stay positive. And where do we want it? We want to know where it's less than 0. Less than 0 when it's negative. And so these two intervals will work. Final answer, x exists in the intervals from negative infinity to negative 3. It doesn't include negative 3 because it's just, let me double check, just less than, not less than or equal to. Union 3 to infinity. Whoops, never mind, not 3 to infinity. Union from 0 to 3. Sorry. Okay, there you go. 5 problems here to finish for that first part. We'll finish rational functions, rational inequalities tomorrow. And then hopefully I'll get your test back to you as soon as I can. No promises.